This is going to be a walkthrough video on how to install and set up the IPFS file pin service application. This is a back-end service that builds on top of the cache stack. This is an optional piece of infrastructure that you can add to the cache stack if you've watched the other videos and you're already running a cache stack. You can see this is a dependency diagram and IPFS file pin service on the right, upper right. It depends on the SLP token indexer. So when the indexer discovers a new pin claim, which is a specific type of transaction on the blockchain, when it ingests that as it crawls the blockchain continuously, when it detects a pin claim, it'll fire off a webhook, and that'll tell IPFS file pin service that, hey, a new pin claim came in. Here you go. Here it is. And then IPFS file pin service will evaluate that pin claim, which is a proof of purchase to uh, store a file for a year. That's what a pin claim is, and it will use its connection to PSF BCH API to validate that pin claim. And if the pin claim succeeds the validation, it will then download and pin that file. And the result of several of these nodes across the internet doing the same thing independently results in this file getting redundantly hosted across the network. So that's what makes IPFS pin service valuable, and that's why we're going to go through the steps now to install it. So I've got a terminal set up here. I'm logged into my cache box, which is CB3 right now. I created a temporary directory. I've got my cache stack running here, as in previous videos. I'm just going to expand that. So we've got BCH and main, that's the full node. We've got these two Docker containers that make up the Fulcrum indexer. And then we've got these, let's see, Block Explorer. There we go. I had to turn a few things off. Okay, so we've got BCH main, which is the full node, two containers for the Fulcrum indexer. We've got these three containers for the SLP token indexer, and then PSF BCH API running. So that makes up these four components here. So now we're going to install the pin service and get that running. So one of the first things you want to do is make sure that you have the SLP indexer configured correctly. So this is a second. So I've got this one. This is going to be my working terminal on the left. This one in the middle is I'm also logged into the cache box with a second terminal so that I can look at things. I'm going to go into the where I keep the SLP indexer into production and Docker. So if you watch the video on how to install the indexer, you'll be familiar with this directory structure. So there's the three containers. They each have their own subdirectory. Inside the TX indexer is a is an m file, cat.env. And it's this environment variable here. This is the webhook that will be triggered when a new pin claim comes in. And this is the address where the file pin service is going to live to receive new pin claim notices. So this 172, this is the Docker network on Linux, and then it's going to be running on port 5031. And we put that into this pin API URL. So that needs to be in the M file for both the TX indexer and the block indexer. They'll both notify it when they come in. Sometimes the TX indexer will miss a transaction, but the block indexer never will. That's why it's important that they're in both. You want that real-time effect when the transaction indexer picks up a transaction, but if it misses it, you need to have the block indexer catch it. Okay, so that's the SLP indexer. and it's important that your SLP indexer is synced and running correctly. And it looks like this. If I look at the TX indexer, I'm getting these notices that it checked the ZMQ every few seconds. So that means it's fully synced and it's just sitting there looking for new transactions to hit the mempool. Okay, so let's get started. Now that we have SLP indexer set up correctly to do the webhook, let's install. I'm going to remove this old copy. Let's install and run the file pin service. So to do that, I'm going to go to the GitHub page. So github.com under the Permissionless Software Foundation group, the IPFS file pin service. Most of what I'm going to cover in this video is available in the README. It talks about the endpoints you can access, the config variables, and we're pretty much just going to read through this thing. But the first step is to clone it. And production Docker directory where the Docker containers live in most of these PSF repositories. So if you just build and run it, it will work. Let's build it. And out of the box, if you just do this and you don't change, but before I run it, let me show you this start production.sh bash shell script. This has the environment variables. And so out of the box, by default, this has the Web 2 interface disabled. We're going to enable that here on the cache box in a minute. But out of the box, it comes like this. And so if you're not running a cache box, but you want to play with this software, like as a developer, you can just run this and get it up, and it will use the free BCH infrastructure, which is a little slow. But at least you can start to interact with this if you want to dig into the IPFS stuff. We can see it here and we can follow it as file service. And when it first starts up, the REST API server is not actually accessible because first it's going to go through a step where it validates the right price for pinning the cost. We target 1 cent per megabyte, and that price is set by the Minting Council, and it's a decentralized protocol. And so the first thing it's going to do when it starts up is it's going to try and validate the right price and get the current right price from the blockchain. And if it fails in that, it'll fall back. But I think it's so slow. Get right price. Yeah, it's just so slow. It's having a hard time coming up. So I'm going to skip past that, and I am going to go ahead and bring this back down. And I'm going to configure the file pin service to use the Web 2 interface because I've got PSF BCH API, the REST API, running locally. It's going to be much faster. And it's also that way I'm eliminating a dependency on a third party. I can be self-sufficient. So I'm going to edit that start production file. And you should also change this mnemonic. You can do that by going to wallet.psfoundation.info, create a new web wallet, and copy that 12-word mnemonic from that wallet in here. That's a fast way to do that. And give it your own unique name on the IPFS network. That's a good thing to do. And there's more little config settings like this in the README if you want to read through. But the main change you need to make if you're running a cache box is you need to enable this Web 2 interface, and you want to point it at your instance of PSF BCH API. So that's going to be port 4952 and v6 prefix currently. So now with that running, I can bring the container back up, and let's monitor the logs as it goes through. And you can see now it's launching right into this validating approval transaction. This is actually like kind of a significant computational load to do this, and also like an API load, but it only does it once at startup, and it's important that it gets the correct price from the minting council directly from the blockchain with no intermediary. And then if it fails, it falls back to a safe. The current price is hard coded. But in case those were ever to get out of sync, the truth is on the blockchain, not in the code. And so that's why it's important that it does this. So anyways, it's started up and it's running. So we can monitor that here, and then we can monitor the TX indexer here. So let's pin a file and make sure that this is running correctly. So I'm going to use my OpenClaw bot to generate an image. Generate an image of a donkey balancing on a ball. Then resize it as a token icon. Then post the image to this Telegram channel. All right, so I'll give it a minute to do that. Okay, so there's our image. So let's upload this image to the IPFS network. Let's see, I want to download it. Okay. And then to test, I can go to explorer.psf-fpp.com. That stands for Permissionless Software Foundation File Pinning Protocol. And then navigate to the upload page. So here I'm going to pay directly with PSF tokens since I have some in my wallet. If you just have Bitcoin Cash, you can leave that untoggled and pay with Bitcoin Cash. And I'll grab my new picture. And so right now it's calculating what the right price will be. It'll be under a megabyte, so it'll be the same price anytime it's a megabyte or less. And now I can upload it to a staging server, which is adding it to the IPFS network, but it's not issued the pin claim, and it's not going to pin it across the network yet. But then I can hit pin file, and now the pin claim's being generated, the PSF tokens in my wallet are being burned, and we will see the proof of burn and the pin claim come up here in the SLP indexer. And then when the SLP indexer detects it, that'll fire off a web hook to the file pin service. And that's what we want to test. Oh, there it goes. Okay, so pin claim found, and we saw the file pin service react to it, and now it's in the process of validating it, which it did. The file size, and it successfully downloaded it, and it successfully pinned it, and the validation succeeded. So this tells us that it is running and it's set up correctly. And now we can shut down our terminal and know that the service is running the way it should be. And as new pin claims come in on the blockchain and people want to pin files, this will detect them, validate them, and download them. And now we can have our own local copy of all the files getting pinned to the network.